Welcome to the lecture of our final subtopic for this chapter, which is oxides. Okay, let's discuss on about what is oxides and the trend of oxides in the periodic table. Oxides is a compound when oxygen reacts with an element. And almost all elements can combine with oxygen except for the noble gases. And most oxides can be classified as acidic or basic, depending on whether they produce acids or bases when being dissolved in water or react as acids or bases in certain processes. And some oxides are amphoteric, which means they can display both acidic and basic properties. Okay, oxides are chemical compounds with one or more oxygen atoms combined with another element. For example, we have 4 moles of sodium atom in the solid form reacts with oxygen gases and produce the oxides of sodium oxide. So across a period, the acidity of oxides increases due to the electronegativity increasing from left to right of the periodic table. And going down a group, the acidity of oxides decreases or oxides becoming more basic. Nonmetals tend to accept electrons, thus form an ion, and nonmetals react directly and indirectly with oxygen to form oxides, which have acidic properties. So how do we know if that oxide is basic or acidic? So for acid oxides, for example, here we have sulfur oxides and also phosphorus oxides. When sulfur oxide, we react with water, so it produces an acid solution. We know from when we test the pH or by using this litmus paper. So in another example, phosphorus oxide being reacted with sodium hydroxide, so we get a salt in a solution. So we know that phosphorus oxide is acidic because it undergoes neutralization reaction with base to produce salt. Metals tend to lose electrons, thus form cation. So metal also can react with oxygen to form oxides, which have basic properties. So we have sodium oxide and magnesium oxide. So sodium oxide reacts with water to produce sodium hydroxide. I think this is the most common bases that we know, sodium hydroxide. And magnesium oxide react with hydrochloric acid to produce magnesium chloride, salt, and water. So we know that magnesium oxide undergoes neutralization reaction to produce salt. It means that both oxide from metals are basic. There are also oxides with neutrality, so it does not they do not react with either acids or bases. For example, here we have carbon monoxide, nitrogen monoxide, and also dinitrogen oxide. So nitrogen and carbon can also form acidic oxides other than only neutral oxides. Okay, now we go to the amphoteric oxides. For example, zinc oxide, aluminum oxide, lead oxide, and titanium oxide. So these amphoteric oxides can act as acid or base depending on whether it donates or accepts electrons. And these amphoteric oxides, they tend to be the semi-metal or weaker metals. And these being amphoteric oxide, they can react with both acids and bases. For example, here we have aluminum oxide reacted with hydrochloric acid to produce aluminum chloride. And it also can react with the base, so sodium hydroxide, to produce this salt. These are the elements in period 3, and this is the formula of oxides that element 3 forms when it reacts with oxygen. So metals, sodium and magnesium, form basic oxides, whereas the non-metals form acidic oxides. The metals here and metalloids somehow form amphoteric oxides, and silicon is unreactive. And for the molecular structure, these metals, as you know, form ionic compounds, whereas these non-metals form molecular covalent compound. And silicon, as I've mentioned, exists in a giant network, and therefore it reflected high melting point for these metals, and the non-metals represent a relatively low melting point, and with the giant network, silicon has high melting point. So you can see there is a gradual transition from basic to acidic character, reflecting also a transition from metallic to non-metallic nature. Now we have come to the end of our periodic tables chapter. So let's summarize some of the properties that we have learned throughout this chapter. Okay, first you have to understand the concept of effective nuclear charge ZEF, which increases across a period from left to right. When you understand ZEF, you will also have to understand the shielding effect provided by the added electrons into the orbitals going down a group, and this will also relate with the atomic radius of the going down a group and also across a period. And then after that you will have to understand about the ionization energy, the electron affinity, and also the electronegativity. uh, and finally we learn about the metallic character, and also some of the physical properties of the elements, or the trends of physical properties such as boiling points and melting points, which differ across a period or down a group according to the structure of the elements, and also about the oxides of periodic elements that varies and changes according to the metallic or non-metallic character of the elements. Now you have come to the end of this chapter. Congratulations. Thank you for your attention, and if you have any question regarding this chapter, please enter the code to be a member in my team, Camp Dr. Nur Shafiza. You can ask the question by sending chats over there during Q&A session. I will answer you, inshallah. I wish you all the best and have a good day. Bye-bye. Assalamualaikum.